In the northern sky, tucked into the constellation of Pegasus, there's something the naked eye can't see. No brilliant color, no swirling arms or glowing gas. It looks at first like a mistake in a photograph. Just 5 tiny dots, 4 bright, 1 faint, arranged in a near-perfect cross. But if you know what you're looking at, those dots carry one of the most astonishing stories the universe has ever told. It starts not with the dots, but with the space between them. Roughly 400 million light-years from Earth, there's a galaxy. It's nothing unusual on its own, a hazy blur of stars and dust floating in the dark. But this galaxy sits directly in front of something much farther away, almost unimaginably far. Behind it, at a distance of about 8 billion light-years, is a quasar, one of the brightest, most violent objects in the cosmos. A quasar is what happens when a galaxy's central black hole starts devouring matter so fast it glows with the energy of 1 trillion suns. The light from that distant quasar has been racing across the universe for more than half the lifetime of everything, until it ran into something. It didn't stop, it bent. That foreground galaxy, by simply existing, by being massive, bent space-time itself. The gravity of its mass curved the fabric of space like a lens. The quasar's light, instead of moving in a straight line, followed those curves, around the edges, through the dips. And what reached Earth wasn't a single dot of light. It was 4. 4 distinct paths, all from the same source. 4 versions of the same thing, each arriving at slightly different times, from slightly different angles, making a cross around the center galaxy. We call it the Einstein Cross. And it is not a trick. It is not a reflection. It is not some visual glitch of overlapping objects. It is light, ancient, furious, uninterrupted light, bent by gravity into a shape that looks almost too perfect to be real. Back in 1915, Albert Einstein laid out the idea. His theory of general relativity said that mass curves space, and light, which always follows the shortest path through space, would bend along with it. A few years later, this was tested during a solar eclipse when starlight was seen to bend slightly around the edge of the sun. But that was a tiny deflection. What Einstein didn't expect, what he once said would probably never be seen, was a full gravitational lens. Light so sharply warped by a massive object that it would split, multiply, and surround the lens like a halo. But then came 1979. Astronomers using the Kitt Peak National Observatory in Arizona found something odd. A quasar that seemed to be in 4 places at once. At first, no one could quite believe it. But by 1985, with better data and careful observation, the truth became clear. These weren't 4 different quasars. They were 4 views of the same one. The background quasar, the lensing galaxy in front of it, and the alignment of Earth, all lined up just right to paint a perfect cross in the sky. It became one of the most beautiful confirmations of Einstein's ideas. Not a number, not a formula, but a picture. A real image of gravity's subtle power. And here's where the wonder deepens. The Einstein Cross might look like 4 galaxies arranged in a perfect cross, but they're actually all the same galaxy, or more precisely, the same light from one quasar far behind it. The light has been bent by gravity as it passes around a galaxy in front, creating 4 separate images. But here's the strange part. Each of those 4 points isn't showing us the exact same moment, because the light took different paths to reach us, some longer, some shorter, some curving more. Each beam arrives at a slightly different time. Imagine shining a flashlight around a mountain, and the beams curve through different valleys. Some will reach you faster than others. Now swap the flashlight with a galaxy's light, and the mountain with gravity itself. That's gravitational lensing. So when we look at the Einstein Cross, we're not seeing one thing 4 times. We're seeing 4 versions of the same thing, separated by time. Like hearing the same voice shout across 4 different canyons, each echo arriving just a little later than the last. It's one of the few places in the universe where we can watch time itself, split and stacked in front of us. And there's even more happening under the surface. The lensing galaxy, the one doing all the bending, is not smooth. It's filled with stars, dust, gas, and dark matter. As those stars pass in front of the quasar's light paths, they create tiny, unpredictable flickers. This is called microlensing. To the naked eye, those flickers mean nothing. But to astronomers, they are pure gold. Each tiny change in brightness helps us map the internal structure of the lensing galaxy, how its mass is distributed, how dark matter flows through it. Even details about the quasar's own structure can be teased out from those changes. So in one image, a handful of faint dots, we get a cascade of discoveries. A quasar from the early universe, a foreground galaxy acting as a gravitational lens, 4 time-delayed views of the same object, and a chance to watch gravity in action, bending, and shaping light itself. But the real beauty of the Einstein Cross doesn't come from the science alone. It comes from the shape. Because it's not just that the universe did this, it's that it did this with such precision. 4 perfect points, arranged in a pattern so clean and symmetrical, it looks like a symbol, a cosmic cross, a lens-shaped mirror, holding 4 glowing shards of an object 8 billion years away. It's the kind of thing you might expect to see in a cathedral, carved into stone, or painted on glass. Instead, it's drifting out there in open space. A geometric whisper from the laws of physics, hinting at symmetry behind the chaos. It reminds us that even in distortion, there can be harmony. The Einstein Cross is an accident in a way, a coincidence of alignment. The quasar, the galaxy, and us, all positioned just so. Move the galaxy a little to the left, and the illusion disappears. Tilt the quasar a little off-axis, and the cross becomes a blur. This perfect beauty exists because of timing, alignment, and gravity. And it won't last forever. Over millions of years, the alignment will drift, the image will warp, the cross will vanish. But for now, it's there for us to marvel.